Okay, so now we're going to do an example of this binomial expansion where it's not just x plus y to the power n, like these ones here. If it's x plus y to the power 3, you get this, and so on. It's going to be something different than x plus y. It's going to be, for this example, 2x minus 3y. And since all our formulas have to do with a plus in the middle, we're going to change this to a plus to make it easier to look at. And we're going to make it as 2x plus negative 3y to the exponent 4. And that way we can think of the first term as 2x, the last term as negative 3y. In these formulas here that we've done, we've got an x and a y in them, which is fine. But because we have x's and y's in our question, we might want to write it with something else like an a and a b, which I'll show you in a minute. The expansion of the exponent 4 expansion is going to look like this one here that we've done, x plus y to the 4. You see the coefficients are 1, 4, 6, 4, 1. So the numbers in front of the terms, the variables. Okay, and how do we get those again? Well, we get them from Pascal's triangle. So this is when the exponent is 0. This is when the exponent is 1. The coefficients are x plus y, 1 and 1. Then the exponent is 2. It's x squared plus 2xy plus y. This is when the exponents are 3, and this is when the exponents are 4. So in this row here, these are the coefficients of the terms in the binomial expansion of x plus y to the 4. Okay, so you can see here, x plus y to the 4, 1, 4, 6, 4, 1. And in here, we're looking at the fifth row, so 1, 2, 3, 4, 5. Why is it the fifth row and not the fourth? Well, because the first row corresponds to the exponent of 0. Then 1, then 2, then 3, then 4. So 1, 4, 6, 4, 1 are the coefficients again. And how do we get the other terms in the expansion? Well, we notice that if this is 4 here, we're going to have x to the 4 to start with, and then it goes down to 3, then 2, then 1. And as the x exponents go down, the y exponents go up. So the second one starts with y, then y squared, then y cubed, and y to the 4th. Okay, so I'm going to take a look at this, the formula that we would need for this. Well, it's going to be, instead of x plus y, let's just do a little bracket here. So a plus b to the exponent 4, well, instead of an x plus y. Well, we're going to write down the terms. So we're going to start off with a to the 4th. Okay, then we're going to do plus, and the coefficient of the next term. So Pascal's triangle here, the fifth row, the coefficient is going to be 4. So I put a 4, and then I put a cubed b. So the exponent of a goes down by 1, and then plus the next one in that fifth row is going to be a 6. So 6. Then it's going to be a squared, b squared. So the exponent of a keeps going down, b keeps going up. The next coefficient is 4. And it's going to be a times b cubed. And then the last one is plus b to the 4th. And you can see the symmetry in this. Okay, so that after the middle it goes the same numbers. So in this case here, what we're looking at now is, what do we substitute in for a and b? Well, a is the 2x, and b is the negative 3y. So a equals positive 2x, and b equals negative 3y. And that's what you're going to sub in for those, okay? Because those are the a and the b. So I can write here now that 2x minus 3y all to the 4 equals, well, a is 2x, so 2x to the 4 plus 4 times 2x to the 3 times negative 3y, because that's b, plus 6 times 2x squared times negative 3y squared plus 4 times 2x times negative 3y cubed plus negative 3y to the 4th. Okay, so that corresponds to these pieces here, just subbing the a and b in. And now we're going to simplify this by distributing in the exponents. Okay, using our exponent laws here, this becomes 2 to the 4 x to the 4, then plus 4 times 2 to the 3 and x to the 3 times negative 3y plus 6 times 2 squared x squared times negative 3 squared. The negative 3, the squared must be outside the brackets because you're squaring the negative 3, not just 3. And then y squared. And 4. 4 times 2 is going to be 8. So I'm going to do 8x here. And then negative 3 cubed y cubed. And then plus negative 3 to the 4 and y to the 4. Now we simplify again, and we get 2 to the 4 is 16, x to the 4. And then here we've got 4 times 2 cubed. Well, 2 cubed is 8, so 4 times 8 times negative 3 is negative 96, so plus negative 96. And that's going to be x cubed y. And then, so I'll put that in brackets there because plus a negative. Then it's plus 6 times 2 squared. 2 squared is 4. So 6 times 4. And then negative 3 to the 2. Well, negative 3 to the 2 is going to be positive 9. So 6 times 4 times positive 9. Okay, and that's going to be 216. Okay, so plus 216 x squared y squared, and plus, well, 8 negative 3 cubed, well, that's going to be negative 27. So 8 times negative 27 is going to be negative 216, and that's going to be x y cubed, and then plus negative 3 to the 4, well, that's going to be a positive, and that's 81, so 81 y to the 4. I'll clean that up just a little bit. 16x to the 4 minus 96 x cubed y plus 216 x squared y squared minus 216 x y cubed plus 81 y to the 4, and that's what expansion would look like. Now, as another example that you can pause and try here, so I'll put it up, and then you can pause and try it, and then I will plop on the solution to it. Okay, so that's that one. Another example is right here. You could try this one, so you can pause and try it. And now I'm going to plop up the solution. So here it is for that one. So the expansion of this one is to the 5th. So a plus b to the 5, using Pascal's triangle to get the coefficients, 1, 5, 10, 10, 5, 1. It's going to be the 6th row of the Pascal's triangle. And the a starts at a to the 5, a to the 4, a to the 3, a to the 2, a to the 1, and b goes down in the other direction. And now you just have to substitute in x squared for a and negative 2y for b. And this is what it should work out to. So you can give that a shot.